Hi, my name is Gokul. I love engineering and I love computers. So today I would like to talk a little bit about my project, whose objective is to cover our future. Now this is a complex project that was done in collaboration with multiple academic and private institutions. The goal or the motivation that is driving this project is that the energy demand of our world are clearly increasing and majority of energy sources today are non-renewable in nature. Now, one untapped potential of renewable energy resource is wave energy harvesting. But harvesting energy from waves is an extremely challenging task. The salt water is an extremely corrosive environment, the salt corrosion system, and it makes maintenance and building of structures extremely difficult. We also have to minimize our ecological footprint, and we need to come up with a system that can handle large unpredictability and variance in the wave energy that we're trying to solve. Now, this ability to transfer kinetic energy into electrical energy from ocean waves requires a complete rethink of the transducer technology that we need to create. The transducer technology that we are using is dielectric elastomer generators. Are simple materials that can act as capacitors in certain charges. And when we add the elastomer component, we can stretch these pieces of dielectric material, changing their capacitance. And we can use this property in specific configurations to act as a generator. These generators have been shown in lab to have up to 90% conversion efficiency of mechanical into electrical energy. My contribution to this project was to show that DEG-based wave energy harvesting is not only viable, but is also cost-effective. Over a period of 1 year, there was multiple iterative generations of prototyping. I was able to show that a DEG system can equal the performance of conventional existing systems. We started off in our first generation prototype with a simple 12-volt system that can power and flash an LED. Over the next few iterative generations of prototypes, we're able to introduce specific concepts and specific techniques and specific design that together allowed us to improve the performance of the system. In the second generation and the second generation prototype, I introduced something called the rack and pinion perspective. And this was able to increase the operating envelope of a DEG. In the third prototype, taking inspiration from the world of origami, I came up with a technique called deep isolation that allowed us to improve the performance of the system. At this point, we were able to break the 500 volt threshold. And then, from a fourth generation prototype, I introduced a concept known as isoplanetic sphere, which, coupled with the previous generational improvement, we were able to cross the 1 kilovolt threshold barrier, and at 1.35 kilovolts, we were able to exceed the performance of any existing wave energy harvesting system. And our final prototype that is being tested and evaluated in actual operational conditions, we have seen up to zero point 0.1 megawatts of energy being produced in a day. That means 3 of these tabletop sized systems can cover an entire HDD block worth of our energy needs. And this can be done at an extremely cheap cost. Even at the prototyping stage, it only costs $635 to build one of these systems. So at roughly $1,800, we can power an entire block of systems in a renewable energy source. And this is a groundbreaking advancement. But for any transducer mechanism to be viable, it shouldn't be limited to just one use case. While I was looking at the macro level applications of this technology, the team that I was a part of was also looking at micro level applications of this technology to power pacemakers. We also have other team members looking at how we can exploit this transducer to power wearable technology. The future of this system is bright. It can power all the way from the micro scale of devices, and the future is indeed bright, both literally and figuratively. Thank you.